All right, let's take a look at where we're at here. So first off, just a reminder, Mr. Coonan's quote of the day, he quoted himself again today. So don't take the shortcut if you get lost. Very simply, he's talking about those 30, 60, 90, 45, 45, 90 shortcuts. Meaning if they don't make sense, don't use them. Okay? You always could still do sine, cosine, tangent. You don't have to use them. They're just an advantage if you understand them. So just a heads up on that. And again, Mr. Coonan's root of success, reminding you again, try to get his 8 hours of sleep as much as you can. Got to take care of your body. He talked about the 3 main ones: sleep, breakfast, and water. Those are the 3 main things to take care of your body every day so that you're functioning all right. All right, let's take a look at the warm-up here. Let's see what you came up with. Number 1, let's start there. What kind of problem? How do I solve number 1? Cameron, what do you got? Okay, so if we take a look, how'd you know it was cosine?
You have the one leg and 5.
Okay, and the leg that you have is your adjacent leg. 112 is the hypotenuse to that triangle, and therefore adjacent and hypotenuse, that's your cosine ratio. It's the only one that works with those 2 pieces. So if we set this up, I've got the cosine of 23 over 1 equal to adjacent over hypotenuse. Okay, so we're taking a look at those 2 pieces. So now we've got a proportion. Let's cross multiply. X times 1 gives you X. 112 times the cosine of 23. And remember I told you first semester, don't go to the calculator until the variable's by itself. In this case it is. So now we go to the calculator and type it in to see what we come up with. Camden, what'd you get for this one?
I got around 103.1.
Okay, 103.1, that sounds about right. And there's your final answer for that one. So there's a review of a cosine type of problem. Okay? Now let's take a look at problem number 2. What do I use on 2 to figure this one out? Sine, cosine, tangent, inverse trig, Pythagorean theorem, shortcuts. What do we do? We got a lot of options. Lots of options. What do we do here? What do we think? Ari, help me out here. What do we do? Okay? And because it's an angle measure, it is inverse sine. Very good. So right away, because you're looking for an angle measure, you know it's going to be some sort of inverse trig we're going to use. And then the question is, based on the 2 pieces, is it inverse sine, cosine, or tangent? And so if we take a look, x equals 8 is the opposite leg, 10 is the hypotenuse, and therefore opposite to hypotenuse, that once again is your sine ratio. But we're going to do inverse sine because we're looking for an angle, not a side leg. And then we always take the ratio that we set up is always the ratio of what I'm taking the inverse of. So if I'm doing inverse sine, I set up the sine ratio. In this case, 8 over 10. If I was doing inverse cosine, I would set up the cosine ratio, and so on, and so on, and so on. And therefore, Ari, what'd you get for this one when you typed that one in?
Approximately
53 point, what was it? 13? Okay. So approximately 53.13 degrees. There's your answer for that part. I didn't ask you this, just as a heads up, but if you take a look back at the triangle, anybody tell me off the top of their head what the other leg is? Where did somebody say it? 6. That's a 6, 8, 10. That's a 6, 8, 10 Pythagorean triple. So again, it wasn't part of the problem. I didn't ask you that, but if you notice, 6, 8, 10 Pythagorean triple, you have it, you can move on to the next part. Okay. All right, let's take a look. Number 3. If we take a look at problem number 3 here, what do we do on this one? Devin, what do you think? What did you use on number 3? Okay, and why tangent? Which 2 pieces am I working with in this triangle? The 2 legs. That's why it's a tangent problem. Anytime you're working with 2 legs, it's always a tangent problem. Okay? And so in this case, if we set it up, tangent of 50 over 1 equal to, remember your tangent ratio is your opposite leg to adjacent leg. Well, opposite leg is x, adjacent leg is 45. So we've got x over 45. And once again, now we're right back to like what we were doing in number 1. Cross multiply, x times 1 is x. 45 times the tangent of 50. And x is by itself, so we type it in. What'd you get, Devin? What's the answer to this one? 53 point what? 63. Okay, that seems about right. And if I were to tell you that when I look at this triangle, I know the answer's got to be bigger than 45. Why do I know that? How do I know for sure that the answer is bigger than 45? Well, yeah, you know.
Because it's the long side.
Okay, yeah. You take a look. If you put in the missing angle, that's a 40-degree angle. Bigger angle is always opposite the bigger side. Okay, so if that's a 50-degree angle, I know that that side's got to be longer. Smaller angle, therefore that's the smaller leg. Okay, so those always go together. So I knew the answer had to be bigger than 45, and sure enough it is. So we're good. How about number 4? What did we do on this one? Casey, what'd you do on 4? What'd you use? Okay, if you take a look, 35 degrees is my reference angle. Once again, we're working with opposite and hypotenuse, so it is correct, it is a sine problem. If we set this one up, sine of 35 over 1, equal to, by definition, opposite leg over hypotenuse. In this case, 15 over x. Once again, we cross multiply, but this one's a little bit different than the others. And that is because x is not by itself when I cross multiply, so what do I have to do then, Casey? Okay, yep. Very good. We have to go through and rather than multiplying by the sine of 35, we got to divide it out to get rid of it. So we divide by the sine of 35 to get x by itself. And I cross those out. Now x is by itself. And there's what you're typing into the calculator. 15 divided by the sine of 35. And on this one, what'd you get, Casey? What's the answer on this one? Yep, that sounds right. 26.15 is your answer. Again, looking at the picture, I know it's got to be bigger than 15 because it's the hypotenuse of the triangle, so I know it's got to be the longest side. So right away, you know you should get an answer bigger than 15. All right, last 2. Let's see what we come up with here. As you take a look at the last 2, these are the ones where you now have options. Okay, this goes back to Mr. Kunin's quote of the day right here. Here you have a 30, 60, 90 triangle, which we talked last week about shortcuts in order to solve those. Over here, you've got a 45, 45, 90 triangle. If they don't make sense, and I noticed as I was coming around, I just was looking to see how people were doing things. Some people in here use the shortcuts. Other people did it with sine, cosine, or tangent. Which way is right? Both are. Okay? It doesn't matter which way you do it. The shortcuts are just that. If you can do it correctly, they'll get you there quicker. But if you can't do it correctly, then there's no point in doing the shortcut. Okay? So avoid it if that's the case. Because we already did some trig problems, I'm going to do them with the shortcuts just to remind you. So first problem here, we got a 30, 60, 90, and I've got the short leg. Therefore, what do I do off of that? What do you think, Camden?
Double it to get the hypotenuse.
Yep. Hypotenuse is always double the short leg. Therefore, I know that's 16. And what about the long leg then, Camden?
You would take the short leg.
Yeah, it's always the short leg times the square root of 3. Therefore, 8 square root of 3, and we're done. Just like that. That's the benefit of knowing the shortcuts. If you know the shortcuts, we just got 2 answers in less than 20 seconds. If you don't know the shortcuts, you can still get them. But you're going to have to do sine, cosine, or tangent to get there, and it takes you a little bit longer to do it. So, there's what you should end up with. Okay. And finally, number 6, Emily, why don't you help me out on this one? What'd you do for x and y?
For x, I just moved the 6, so other side.
Okay.
And then, for the y, I took 6 times 2, and I got 8.49.
6 square root of 2, which is 8.49 approximately. So 2 parts here, remember in a 45, 45, 90, if you've got 2 equal angles, that means you've got 2 equal sides. Okay, those have to be, there's a line of symmetry right down the middle. So these 2 have to match up if they reflect. And then, again, from that point, you can either use Pythagorean theorem, you can use trigonometry, or if you remember the shortcut, the hypotenuse is always the leg. times the square root of 2, which in this case is 6 square root of 2, or 8.49 approximately. So this, by the way, should give you a pretty good idea where you're at right now in this chapter, because it had a little bit of everything. 3 problems of trig, 1 with inverse trig, and 1 with each shortcut. This is pretty much what we've done in chapter 5 so far. Okay, so just to give you an idea, what I want you to take a look at then is in this, I told you I gave you a packet. Let me go to that then. Come on. Get through, we already did all that. So a couple of things with the packet that I want to make you aware of. And I'm guessing that most people are probably in pretty good shape here. But first part, the trigonometry review. Box right here just reminding you again of sine, cosine, tangent ratios, adjacent leg versus opposite leg. If you take a look at some of the examples down here, notice here's 2 sine examples right here. So if one of the things, if you're struggling with sine or when to use sine, here's a couple of examples. Here's the work that goes with each one. Here's the explanation. There's a whole bunch of stuff here that you can take a look at. If you go to the next page, same idea, except now they give you a couple of cosine problems. Okay? Once again, they set them up, so here's the actual work. And then over here, they're walking you through what they're doing and why they're doing it. Okay? So you can take a look at that one. If we go to the next page, now this is a whole page on inverse trig. Notice 4 problems where you're finding angle measures. So if this is something that you're struggling with, what you have, here's 4 different ways of doing those problems again, and the explanations that go with them to kind of explain why you're doing inverse trig and how to do inverse trig. Okay? If we keep going, so that's all the trig stuff, and then here's what we did last week. Here's your special right triangle problems. Here's the relationships that should be on your toolkit, okay, for both parts. And then down below, they give you a few examples, and the next page is just a bunch of explanations of those examples, okay? So these explanations goes with the examples from there. So this is kind of today's a review day. This is a review packet. We wanted to give you that, so that if you're struggling with any of this, you've got examples and explanations for every single thing that we've covered so far. Okay, so use it if you need it. Then if you take a look at the next, then they threw in some Pythagorean triple stuff too. But then if you take a look, the next thing says trigonometry practice. Starting right here, I believe, off the top of my head, I believe there's 18 questions. This is your first worksheet for semester 2. Okay, so it's not one of the other practice to learn worksheets. This is your first assignment. This is the first one that's due by Wednesday. And so as you go through and you take a look at this one, the other thing I want you to notice is the very last page of your packet is the assorted answers again. All the answers are there, they're just not in any specific order, okay? So with the last about 15 minutes of class, I told you we'd have about 15 minutes, I want you to go through and start working on this. If you know there's something you're struggling with, take a look in the packet in the appropriate spot. If it's sine, cosine, tangent, inverse trig, and then we can always go over that if we need to. But otherwise, I'm going to give you some time to work, ask questions, make sure you're checking your answers, and I'll just kind of come around and check on you at that point. Okay? Let's go to work.